Some problems that you're going to come across in trigonometry require you to use a bunch of different methods, and sometimes it won't be entirely clear where you need to start, so you need to have a look at a problem and figure out what you need to find out first. Let's have a look at this example. We need to find x and y. We have two right-angled triangles, so it's really just a matter here of working out what to do first. Now, if you look at this triangle, there's not enough things in it that we know for us to be able to start here. So we're trying to find y, and all we know about the triangle is that it has a right angle and it has 32 degrees. Because we don't know either of the other two sides, we really can't get much from that triangle. So it's clear we need to start with this triangle, and the first thing we'll need to find is x. So start by thinking, all right, we've got the opposite side from 40 degrees, and we've got the adjacent side, so we're going to need to use tan. So we start by saying tan of 40 degrees equals x over 15. And so making x the subject here, we need to just multiply both sides by 15. So I like to write the x on this side, and on the other side I'll have 15 lots of tan 40. Now at this point you can reach for your calculator and figure out what that comes to. 15 times tangent of 40 degrees is 12.586. Now it's a long decimal there that doesn't recur. So I can put in an approximation for this, 12.59 say, let's round that to 2 decimal places. But here's the thing, I'm going to need to use this length over here. If I want to, I can put that into my drawing. It's about 12.59. Now I've put that symbol to show it's about 12.59, it's not exactly 12.59. Now when I need to use that later, there's two ways you can get it. You can either go ahead and make your next calculation and then use the A and S button, which will recall the last answer that you had in there. The other thing you can do is you can store that exact value in your calculator. If you're not sure how to do that, let's have a look at it now, because this is a really handy feature. To store it, can you see the little letters STO just above the RCL button here? Now it's in yellow, that STO, which means we need to hit Shift to access the store function. So press Shift and then press the RCL button. That will allow you to store it. Now you decide where you're wanting to store it. And the storing buttons are the red ones, A, B, C, D, E, and F. So I'm going to store it as A, which is the first button here, which is actually the little negative button. And if I put that in, notice how on my calculator it says answer is now A. So my calculator will now remember that as the red A symbol. So I can now hit all clear and move along with the rest of my problem, knowing that I've stored the exact value of this, so I'm not going to increase my error by rounding off and then using that rounding off in the next part. So in the next part now, to find y, if we know this length and we have our 32 degrees, then what we have relative to the 32 is we have the adjacent side that we're interested in, and we now have the hypotenuse. So adjacent hypotenuse is cos. So we can write cos of 32 degrees equals adjacent, which is y, over our 12.59. Now here, I'm going to put 12.59 ... to remind me that not to use 12.59, but to use my stored value. Now to get y by itself, we need to multiply both sides by that 12.59. So y equals 12.59, and you can put your dots there, times cos 32. Now at this point, when you reach for your calculator, you can get that value back up just by hitting the answer button. That's one way. But the other way that you now know is you could press the alpha button, which is the red button, which allows you to use the red A, and just type in A. Now hit times cos 32, and our answer comes up 10.67. So this will now be a good answer, and it uses the whole answer here, not an approximation. So we've got 10.67. We can also now round that off to 2 decimal places. Remember, when you're rounding off, always say what you've rounded it off to. So now we've got our answer for y, and we're done. At the end, you might like to write a nice little statement, x equals this and y equals that. In this example, we have two things to find. We need to find this length BC, and we also need to find the bearing of B from D. Now, this is a good example of a question where reading ahead and seeing what you're going to need to do second maybe helps you to save a little bit of time with the first part, because you've got a choice here with finding BC. Now, you don't know enough about anything in this triangle to find BC straight off, so you need to use this triangle ABD to start. You know all three sides, which means you could use the cosine rule to find any of these three angles. So you've got a decision to make. Which angle will I find? Now, if you chose to find this angle first, that would actually be quite helpful for getting BC, because once you've found this angle, you can then say, all right, I know this angle, I've got BC, and I've got the hypotenuse of this big triangle. And that would be a perfectly good two-step method to get BC. But then for the second part of the question, you'd be having to find this angle, the bearing of B from D. We really need to know this, don't we? So that we can then find what that is. Okay, assuming that this is 90 degrees. So I'm thinking if we need to know this angle, it would be pretty handy, instead of finding this one, if we'd started by finding this one here. Because if we know this one here, we can find this one here. And if we sort of answer the second part of the question first, then we can actually use that and the 22 metres to find BC. So overall, it's still 2 steps to find BC, but we'll get this answer almost for nothing. So read through, have a think before you start, so that you can make a good plan that will save you time. We don't want to find that angle, we're going to start off by finding this one. Okay, so our first step is to apply the cosine rule to find this. So if you like to write the cosine rule out first, that can help you. So cosine of A equals B squared plus C squared minus A squared over 2BC. Now sub in the things that you know. Our angle is this one. Now, if it's big A, what that means is that this is the little a, isn't it? And now, again, we're going against all the naming conventions of these A's, B's and C's and D's. I'm using what I know here about the cosine rule. So be really careful not to get confused between the parts of the cosine rule and how they relate to each other and the letters on your diagram. Basically, I just need to remember to use the 2 sides on either side of the angle I'm using. So I need 20 squared plus 22 squared, and then take off the opposite side squared, which will be our 36 squared, all over 2 times 20 times 22. So plugging all of this into your calculator, you get cos of A equals this, and so then you can find the inverse cos of this part to get your answer. To the nearest degree, we've got 118 degrees. A good strategy is to write what you know on your picture so that you can use that moving forward. Now, if this is 118 degrees, what's this? Well, we simply subtract 118 from 80, and this will have to be 62 degrees, won't it? Okay, now we can go to the second, well, still the first part. We haven't actually found this bearing of B from D yet. We can find that later very easily. But let's get on to first now finding BC. If I use this bit of board over here. So here we've got our 62 degrees, and we're finding BC, which is the opposite side, and we have the hypotenuse 22. So opposite hypotenuse is sine. So we need to write sine of 62 degrees equals BC over 22. Now to get the BC by itself, just multiply both sides by 22. That will get rid of this 22 here, and we'll have 22 multiplied by sine 62 over there. Now I prefer to write the BC first on this side, and then the 22 lots of sine 62 on that side. So BC will be, let's type it in, 22 times sine of 62. Now we've come to a bit of a problem here. Is this exactly 62? And do we want to compound our mistake? So probably the best thing to do is actually just to begin with our, sorry, let me type it back in again. I've got the inverse cos of that. Okay, I've got my answer in here as 117.9, and we rounded it to 118 to use as our nearest degree here, which is fine for that answer, right? But we haven't actually been asked what that angle is. That's just something we're finding on the way. So we should really use the exact value of that. That means that when we found this 62, it's not exactly 62, is it? We need to do 180 minus the answer there to find that it's actually 62 and a bit. Okay, now that's the most recent answer in my calculator. So as I go to type this in, I can hit the all clear button and go 22 times sine of the answer, and it'll put in that exact amount, not exactly 62, but the exact amount. And so BC is 19 point, and we'll round that off now to 1 decimal place, and that's in metres to 1 decimal place. Now when you're rounding off, explain what you've rounded off to. Now it's okay to round off when you're at the end, you just don't want to use a rounded off answer when you're still finding what you've been asked. Okay, so we've got BC, now we need the bearing of B from D. So imagine you're standing here at D and you're giving instructions, so north is straight up this way, and you're wondering instructions of how to get to there. What we actually want is this angle here, isn't it? So think, if this is a right angle, and this is 62, but it wasn't exactly 62, you could use that approximation there again. Or perhaps if this isn't to the nearest degree, it's not really going to matter. Then what we've got here is 90 minus 62. So that bearing is going to be 28 degrees to the nearest degree.